this video, we'll be looking at how to solve an application problem involving an exponential equation algebraically. You may recognize the problem on the screen in front of you as one that we already did in Chapter 4, Section 1. The difference is back then we had to solve it by using a graph to estimate an answer, and now we can actually get a much more precise answer using algebra. So, to read the problem again, Tony purchased a rare 1959 Gibson Les Paul guitar in 2000 for $12,000. Experts estimate that its value will increase by 14% per year. When will the value of the guitar be $60,000? So, if you remember, here's our exponential growth and decay formula. We can plug in the pieces we know and find the one that's missing, which is time. We know the final amount is going to be 60,000. We know the initial amount, little a, is going to be $12,000. And we know that our rate of growth, we're growing, so it's plus, is 0.14 because it's 14%. T, how long it takes, is the only piece that we do not know. So now, though, we can actually solve this algebraically. Remember, the first step in solving an exponential equation algebraically is to isolate the exponential part, which is this part here. So the first thing I have to do is divide away the 12,000. 60,000 divided by 12,000 is going to give us 5. Over here, what we will get is now, I'm going to simplify 1 plus 0.14 into 1.14 raised to the t power. To get the t out of our exponent, we will do the log of both sides, which will give us log of 5 equals log of 1.14 raised to the t. Again, what this lets us do now is bring this exponent out in front of our log. So we will now have log of 5 equals t times log of 1.14. We can divide both sides by log of 1.14, which will give us, if I move over to the right, t equals log of 5 over log of 1.14. And I believe if you type that into your calculator, you should get t to be 12.283 years. Now this is definitely a more precise answer than the one we're able to grab off of our graphing calculator earlier.